Alright, so we're going to talk about definite integrals. So to this point we haven't really understood why we're doing integration. We're just sort of doing it because it's a process that we're getting our head around. I ask you to integrate a function and you do it. The value of what integration is that it allows us to define the area under the curve. So if I gave you a function, you can determine the area underneath it. If we think about speed, how do you determine, if I gave you a speed equation of, I don't get too caught up in the function, but if I gave you a speed function of 10 kilometres an hour for 2 hours, how would you determine what would be the distance travelled? 10 kilometres an hour for 2 hours you would have travelled? 20. If I was to sketch that function, so if I was to sketch very briefly, velocity and time, if this is 10, what does 10 kilometres an hour, what does my graph look like? It's a straight line like this, correct? And how, well, I'll do it for 2 hours. So the distance, remember the distance is the integration of speed, remember that? Is the area under that line. What shape is that? A rectangle. What's the area for rectangle? Length times width. What's the length? What's the width? 2 times 10 is? Magic, correct? Really simple example, but most of our functions don't look like that, do they? I could ask this in my Year 9 science class and they could probably figure that out. But what I couldn't do is do this in my Year 9 science class and ask them to figure it out, but it's the same thing. Very similar process to what we've been doing in the past. Our first step is to integrate. The only change is what happens right at the end. What we see here is that we've got, our function will look like that. What does that squiggly line mean? We've dealt with the dx. What does the dx mean? What's that telling us? We're integrating with respect to x. That's the variable that we integrate with. Does that make sense? These values are the start and end point of our integration. A is our start point, B is our end point. Cool? So I don't want you to get too caught up in what's going on. I'll show you a physical example on Desmos in a second, but I thought I'd go through an example first before we went too far. So if I wanted you to integrate this function between 1 and 3, we'd go through the same process. The only thing that we do different is we're going to put a square bracket around it. So what's the integration of x squared? X to the power of? Divided by? Cool? Plus? So we're going to do this exactly the same, but now we're going to put 1 and 3 here. Poorly drawn 1 and 3. And this next step is the one that really changes. What have I done? 10 seconds to think about what I've done before we call out, but I think Sarah's onto it. What have I done in 10? What have I done, Sarah?
You're substituting the start and end point and you find the range.
So endpoint minus, and I put in which I've just replaced x with my new number. Cool? That makes sense? What's going to happen to plus c minus c? What happens to those?
Plus C plus C.
Cancel that. So what am I left with? 27 over 3 minus 1 over 3. 26 over 3. What am I missing? It annoys me, but what am I missing here? Or units, whatever you want to do. I'll just call it units for now. Units is fine. Sweet. So what changes? Tell me what's different. Integrate it the same way, just put square brackets around. And then after that, I'm subbing in endpoint, first point, subtracting, there's my final answer, cool. Where's somewhere we can get a little bit caught, you reckon? What's something we're going to be really clear with?
Endpoint start point.
Yeah, your endpoint start point, your fractional work needs to be good. Where's a common error that I see?
Would be running like endpoints goes when it's not the goes.
Sometimes kids swap those around, yep. To do with this. A lot of kids, ignore this, they don't do it with C, but let's say I had a different term there. But either way, a lot of kids would do this, right? What have they done? A lot of kids put the negative into one of the terms. You've got to make sure that you're putting it into both terms. If I had a negative something here, what would that become? Positive. So just be really aware of that negative sign. Sweet. Now there's on your Google Classroom, there's a Desmos thing that shows you, just let you fiddle around with, it's an x squared plus e to the power of something, not plus, multiplied by e to the power of something. It shows you what happens to the definite integral. So I think that's worthwhile having a look, and then you're going to jump on 5.2. Tomorrow we're going to look at trapezoidal rule, which is normally how this is introduced, but I think that we should go the other way because trapezoidal rule gets everyone a bit funky.